Hi doctor, good evening. We are presenting our data communication and network group project, which include LAN addressing, configuration, and protocol analysis.
Greeting Doctor, my name is Guo Changzhe. In this project, we design and simulate a small office local area network consists of 4 departments, which they are IT, HR, Finance, and Sales. The network uses a single router, 2 switches, and multiple PCs, and the entire design was implemented and tested using Cisco Packet Tracer. Our presentation has 3 parts. First, I will cover the network design and the IP addressing logic. After that, my teammates will walk through the configuration and our connectivity testing and protocol analysis. Let me start the design. This is our topology. It follows a hierarchical star design. The PCs connect to switches at access layer, and both switches connect up to one central router at the core. We made 3 deliberate design decisions. First, a single router. Because it is a small office, one router can handle all traffic between departments. Adding more would increase cost and complexity with no performance benefit. Second, switch 1 is dedicated entirely to IT department, giving IT its own switch, isolated it in a separate broadcast domain, which improves security and keep its traffic off other department segments. Third, switch 2 is shared by HR, Finance, and Sales. It satisfies the 2 switches limit. And even though these 3 sits in one physical switch, the router keeps them logically separate at layer 3. So each department remains its own subnet. Now, let me explain how we address those subnets. We use clusters inter-domain routing to divide our network efficiently. We started with the block 192.168.1.0 with /24 prefix, which gives us 256 addresses. We needed 4 equal subnets, 1 per department. To create 4 blocks, we borrow 2 bits from the host portion, which changes our prefix from /24 to /26. Now, each /26 blocks contains 64 addresses. After removing the network and broadcast address, that leaves 62 usable hosts per department, which, since each department currently has only 2 PCs, this gives us plenty of spare addresses for future devices, while keeping all 4 subnets a consistent size. A /26 subnet mask is the most efficient choice for our design because 4 subnet times 64 addresses equals 256 addresses, fully utilizing the original addresses space without leaving any unused subnet blocks. Now, let's take a look at how addresses were allocated to each department. This table shows our final addressing plan. Working from the 192.168.1.0 network, each department gets its own /26 block. For example, IT start at 0.0, HR start at 0.64, Finance start at 0.128, and Sales is at 0.192. And as you can see, every department has 62 usable hosts. Notice at the gateway column, the router takes the first usable address in each subnet, which acts as a door for each PC's use to reach other departments. The last address in each block is served for broadcast, and all 4 subnets share the same /26 mask. I will now hand over to my teammates who will demonstrate the network configuration in the Cisco Packet Tracer.
So for the configuration, I set up the router R1 and the both switch. For the router R1, I configured 4 interfaces. The first interface fast00 is for the IT department. Next is fast Ethernet 10 is for the HR department. Then is the fast Ethernet 20 is for the finance department. And lastly, the fast Ethernet 30 is for the sales department. Each interface is the default gateway for each subnet, and I use the no-shutdown command to activate each interface. Because all the subnets are directly connected to the R1, so no static dot are needed. To test the connectivity, I ping across all the 6 subnet combinations. The first packet usually shows the request timeout. It is because the ARP is still finding the gateway MAC address. After that, the next 3 packets all succeed. All 6 combinations are successful, and this confirms that R1 is routing correctly between all the subnets. Use the simulation mode to observe how the packet travels step by step. Before the ICMP ping is sent, the ARP happens first. The PC needs to find the MAC address of the gateway before it can send anything. Only after ARP is resolved, the ICMP packet is sent. The packet starts at PCIT1, then go to switch 1, R1, switch 2, and finally reach the destination PC. At R1, the TTL dropped by 1, and this confirms that the layer 3 routing is actually happening and not just the layer 2 switching. We can also see the other PC on switch 2 show a red cross, and this means they received the packet but dropped it because the packet is not addressed to them, and this proves the subnet isolation is working correctly. Then the reply travel back the same path, and the PCIT1 received the reply with a green tick, confirming the ping was successful. And the time column in the event list also show each hop happening in order, proving the exact path the packet took.
Now we will critically evaluate our own design. We use two switches, one dedicated to IT, one shared by HR, finance, and sales. That shared switch creates four issues. First, broadcast leakage. Since the ARP traffic from all three departments floods the same switch. Second, hairpin routing, where cross-department traffic has to leave the switch and come straight back. Third and fourth is single point of failure at router 1 and manual IP configuration that won't scale. So this is our solutions. The first, VLAN segmentation on switch 2 so that we can separate HR, finance and sales into separated VLANs. This is our top priority since it directly kills the broadcast leakage. We'll pair that router on a stick for inter-VLAN routing, add DHCP for automatically addressing, inter-channel for redundant uplinks, and SEL to restrict traffic between departments that don't need to talk. So this bottleneck wasn't an oversight, it's a deliberate case study for performance analysis. To summarize, we designed a 4-department LAN using CIDR26 prefix subnetting, which split our original address space into 4 equal subnets of 62 usable hosts each and 0 address ways. We verified full connectivity with all 6 crop subnet ping pairs succeeding, and we confirmed the underlying behavior, ARP resolution followed by ICMP delivery using packet tracer simulation mode, hop by hop. Beyond just getting it working, we also identified network real weakness and proposed concrete, technically justified optimizations. Thank you for listening.